things and in my chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not a main thing, really I'm a coder. Coffee stains and in my chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode.
That was not a good contest at all. I got absolutely cooked. Yo, there's a lot of cheaters in that contest. It's crazy. Cause I was like at 14,000 and it went all the way to 13. Man, I got cooked. Too many errors. 5 errors. You can't make mistakes. Take a look at the who in the chat actually did the contest. Who in the chat did the contest? How did everyone perform? How'd you do, man? I got cooked. I got absolutely cooked. I overcomplicated the second question. I could only solve 2 problems too. How fast were you able to solve them? Man, the first one took me 19 minutes and 52 minutes on the next one is criminal. I got destroyed. I was overcomplicating my head way too much. I should have just came up with the most simple solution. Y'all will see my solution and my explanation after. Terrible. I'm so triggered right now. How did you solve? Yo, my ranking's gonna drop like crazy. How are people getting? I have no idea. Yo, B, did you do the contest as well? Nah, it's crazy, yeah. These people are fast with it. But yo, you can see that they literally just the code replay is just like they just external paste it, but they're quick with it. 3 seconds? Oh my god. Crazy. Okay. Let's just like go through the solutions real quick. I gotta study my bit manipulation. So this was my code for number 1. So essentially, let's read over the question. We're given a 2D integer array towers. Second was for loop plus set. Yeah, exactly. That's what I did. Honestly, I overcomplicated though. Because for the second question, I thought it said find all maximal contiguous segments, and then you have to remove each segment one by one. You can't just remove all the segments. But I guess all you just literally need to find. Try the third one. Man, I don't know how to solve the third one. I tried to do a backtracking on the Zor. What did y'all try to do for the third one? I had no idea how to even solve this one. That's what they said. Yeah, I don't know how to solve this one. I couldn't even get the right solution, honestly. So what's the intuition for this one? Yeah, I'm 100%. Let's see what people submitted. Okay, I'll show you guys how I actually how we can actually get this down. Okay, where I need to be able to, or help me coach me into getting an optimal solution to this question. I'm going to paste in my I'm going to paste in the question, my attempts, and the final solution. Question. Yeah, I have a job. Why? Is it because I'm always on lead code? Where do you need a ref? Where are you based? Oh, I don't know. I just started code forcing, so not. I don't know if I can see. I don't know if it's helping me just yet. I'm just gonna. How to get into my job? I by lead coding. So right now I work at Meta, so they just straight up ask lead code questions. Work life balance at Rippling was terrible. Let's see. How do I get this code replay? Did they all solve it the same way? Okay, they all kind of solved it the same way. Shoot. They all solved it the same way. Sue, where were you working at? So, all right, James, let's redrive your final solution from first principles so it feels inevitable, not magical. Why your backtracking gets stuck and why it times out. Your attempt is doing pick a start index, index the block until Zora hits the expected target. Once it hits, recurse. Also keep extending while Zora equals experience while trying different cuts. You're enumerating cut points, and in worst case, you have O of n valid cut points from each index, exponential blow up. Even if you memorize on index, you still have to scan forward to match. So we need a counting method that doesn't try cut points explicitly. Counts how many ways can I end a block here in O of 1. So this is where prefix XOR plus hashmap counters counting errors. This is where prefix XOR plus hashmap. Yo, what's up, man? Run Drash, what's up? Um, Ramsey, can you coach me to get into meta? Dude, getting into meta is go on LeetCode Discuss and everyone discusses the process. It's pretty the hardest part is getting the interview, but once you get the interview, once you get into the interview, it's the hardest part is getting the interview. Once you get the interview, you can know how to pass it. Let me grab something. What about projects? What projects to do? Yeah, I'll make a good let me make a video specifically on that because it's a long topic. Once we finish debriefing on this, we'll get into like career questions and stuff because let's focus on getting this down first. Right, let's download this response. See if we need to. Thanks, bro. Take some notes. Sort of a block via let pxi equals num0 dot 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 to nums I. Prefix zor up to I. Then zor of subarray is j plus 1. So if the bunny boy, what's up? Yo, terrible. Padish, terrible, man. I saw you killed it. You did good. I got destroyed. I just lacked. I think I overcomplicated it, but my rating is gonna tank. 13K. I don't even know. Well, like for this one, it took me a while. What did you rank? What did you get? For this one, I was just slow implementing it for some reason. And then for the second one, I misread. I thought it said maximal contiguous elements. So I thought that meant that suppose we had a bunch of segments. Some segments are length 10, Some segments are length 5, some segments are at length 2. First, we can only pick like the largest contiguous subsegment, but you could just choose all subsegments regardless of the size. If that makes sense. Usually there's a lag for me, but it didn't lag for me this time. Oh shoot. Dude, my Wi-Fi is dookie. Yo, could you repeat that? Yo, why's my Wi-Fi so bad? Treyas, what's up? Yeah, I only solved 2 questions too. Yo, Padish, are you live? Yo, you're right, man. You're right. It's not my fault, dude. I'm dropping like $100 a month on Wi-Fi, and it's dookie. And it's not because the Wi-Fi speed is bad. It just cuts out. Maybe I need like a backup. Should I? Okay, yo, Padish. Next time we should go on live at the same time and discuss the solution or something. We can like discuss how we could do better and stuff. Gotta do some BS training model. Where are you interning at? Oh, Padish, he's also a streamer. He streams. He's like almost at night level, so he's pretty good. Yeah, yo, we need to start like a study group. A study group. Yeah. Yo, Padish, where are you interning at? Yo, Padish, my ranking was going nice and not nice and up to the right, but it's about to tank. I was doing good, ranking pretty good. Ion trading. What's ion trading? Nice. Is it in India? Yo, good luck, man. Good luck. What the hell's a prefix XOR? Pi equals nums 0. Okay, XOR them. Then XOR of subarray j plus 1 to I is Pi XOR Pj. So if a block ending at I needs XOR T. Oh. Yo, where are you gonna be at? Are you gonna move at all or no? Yeah. Yo, me and Padesh are gonna like study together. We're gonna get to Guardian this year. Padesh, let's get to Guardian this year. Let's grind. Me and you, Guardian, bro. Yo, Shreyas, thanks, man. I think we just need to learn what prefix XOR is first. What are the Ramen? What's up? What are the Yes, sir. Yo, email me. I'm gonna send you my email, and then I'll send you a calendar invite. What time do you usually go for dinner? Like, what's a good time to stream? Should we just stream every bi-weekly? Like, you just go live, I go live, but we just hop on the same meet and we discuss solution. What's a good time? We can probably do like bi-weekly fine, yeah. But why do you work tomorrow? You got work tomorrow? Yeah, after the bi-weekly, usually I'll go on like 30 minutes to 45 after the contest. Because after the contest is from 6:30 a.m. to 8 for me. Yo, TP, what's up? And then I take like a 30-minute break, and then I start studying again. You need to know instantly that A is equal 0. Yeah. XOR is associative and commutative. XOR behaves like addition mod 2 per bit. If prefix I is 13 and target is 5, what prefix J must be? What? Yeah, I have a Discord. It's in my channel description. Sounds good, brother. Me. Yo, peace out. Have a good night. What is he even talking about? Okay, how are we gonna study this? How are we gonna figure this out? Oh yeah, you're right. You're right. Yeah, I had to do a system design. Okay, let's just do some simple practice. How do you prep for those? Dude, I have a video series of me prepping for it. I'm sure you. Dude, I have a video series when I was literally while I was prepping for it. So if you go to my mock system design interviews, so when as I was shooting these videos, I was actually preparing for meta. How do you? Oh, yo, Rami, that's sick. Congrats. Do I study the trivia in those? Yeah, I study. I'll just study whatever I don't know. But I don't really. I practice on breadth over depth, so I'll just do as many questions as possible. So I've solved 710 questions. Is MongoDB still useful? Yeah, I think MongoDB is still useful to learn because it's just, at the end of the day, it's just a NoSQL database. Handle King, I probably spent That's over the span of 5 years and doing 3 different recruitment cycles, 3 or 4 different recruitment cycles. So it's been like 5 years, and I don't probably I probably spent like 1,000 hours or more. Now I got a matcha. Yeah, you can. I can do a bunch of I can do so many questions. If I want to get to 1,000, like 300 questions in the next month, I could. But I'm not really trying to spam like that. This is equal to 0. This is equal to 7. Yeah, I'm sad after today's contest. It was hard. I got wrecked. But that's how you know we need to work on our game. So something's 1-0, 1-0. If you do a bitwise Zor, that equals to. Yeah, I'm gonna do the one tonight. Yeah. Cancels out. Cancels out. 7-bit 0. 7 Zor 0 equals just 7. What about 4 Zor 6? When I conduct mocks, I'll tell you what the pass rate is, what even when I would do interviews in real life, cuz I've done probably over 100 interviews on actual candidates, and the pass rate for actual candidates is probably 30%, 20 to 30%. I probably passed 1 in 5 candidates for tech screen. Do your parents live in Philippines or you all moved to US? We all moved to Canada. My parents live in Canada. I'm the only one who lives in the US. 1-0. What is this? 6. What is this? 0, 2 equal 8? This equals this 9. This cancels out to 9. 9 mod or 9 3. What is 9? That's 9 to 10. Have I ever passed a candidate? Have I ever passed a candidate that had good problem solving approach but didn't solve the problem? No. I solved the problem in order to move on to the next step. I'm gonna get a backup Wi-Fi. I'm gonna figure out how to get a backup Wi-Fi. This is ridiculous. Xfinity keeps cutting out. I'm actually gonna report this to them because my bill is way too my bill is huge to be lacking like that. You're good now? No, I don't do meta interviews. But when I was at my first startup, I was at my first start for 3 years, so I started interviewing after my first year. Oh, you're right. You're right. Yeah, you're right. These cancel out. Bobo, what's up, man? Result change. Grouping doesn't matter. Yeah, that makes sense. Okay, yeah. Well, pattern printing. What do you mean by pattern printing using loop? Like coding a Bobo, do you have trouble building out logic for functions? Dude, the best way to learn how to implement is just by doing a crap ton of questions. But try all the different array questions and do easy ones that you can that where you only have to focus on implementation. Once you get implementation down, take harder questions that it's harder for you to actually come up with a logic. Oh, I see. Why was my RL? Why was my IRL pass rate? Because people just couldn't solve the question. A lot of people come in and they just had shaky fundamentals. Not that many people are good at just straight up coding interviews. Nah, I give guidance for sure. I give small hints, but the more hints I give, the more they get dinged. I try not to give too much guidance because I want them to not get dinged. And I'm just doing these interviews the way that they made me do it. Really depends on the company. We don't really want the candidate to fail, but I just had interviews where I gave too much hints and then the person passed it. Then I was wondering, did you pass because I gave you the hint, or did you pass because you're actually good? I don't know if I can make a video like that. V. Yeah, but most of the time, if someone has good problem solving, they're gonna be able to solve it. Like, how can you have good problem solving but not solve it fully? Someone who has good problem solving will be able to solve the problem, but then when they go to implement it, they might be shaky. That's different. But if they can't even solve the problem, I don't see how that's good problem solving. Yeah, there's luck involved as well. 0. Q3. Like, if they missed a small case, yeah, I'll let it slide. If a person, what I mean by someone can't solve the problem is they can't come up with the optimal approach. If they can tell me the optimal approach, then that's there, you get points there. And then it comes to implementation. If you can implement it, then you get more points. If you can't implement it, you get less points. And then you pretty much add it up at the end of the day. Yo, I have a lot of videos on this. That's the thing. Q3 12 to 4. 12. So I'll do is I'll go 0, 1, 2, 3. 0, 1, 2, 4, 8, 16. Right, so if it's 12. We go what's 2 to the power 0 is 1. And then 2, 4, 8, 16, right? 1, 2, 3, 4, 2, 2. I need to do these calculations way faster. 12 is this. Oh no. 12 is this. 12 is this. Damn, you're able to get the fourth question? Coding interview performance. I don't know if it really mirrors job performance, but it's just what you need to do to get the job. But what I did notice is working at a company where everyone can solve leak code mediums to hards feels like everyone's a little bit smarter than the average. What is this equal 8? These cancel out. 6. Why should you just be able to mental math this? Yo, NQ, what's up, man? I'm just studying some Zors right now. Two. Go. 1, 0, 1. Trying to build on my binary fundamentals. What is this? 5. Q6. 1, 2. 1, 2. 4. 8. 8. Okay. 12. 0, 1, 1, 0. What is this? 6. What's the minimum bar to pass the system design? It really depends on the company. Every company does it different. But you should be able to like get an API design, like the requirements API design at least, a little bit of data. If you can get what I would try to do for every interview is be able to get the requirements, get the API design, get the data model, get the high level design, and then deep dive into at least one thing. That should get you enough for one or two things. That should get you into intermediate roles, and then usually The deep dives is where things, if you, the more deep dives or the more complicated deep dives you can do, the higher level you'll be. Q9, P cancels out. Because there's cancels out. J plus 1 to I. No idea. Man, so this is how I study. Okay. Good. Each. So 1 to 9 and so. Binary. Fast. Turn to binary. Yeah, these cancel out. Now we get 6. Work binary. A dot B dot. Okay, we just get B. Y cancels out. We're left with X and Z. I'm not actually sure what they're doing. If they're hiring, honestly, don't look at that. You you would probably know better if you're interviewing, right? The company's so large, so it's not like I wouldn't know that, honestly. It's not something that I look into. Studios, you almost for everything. But just look on LinkedIn. Yeah, I do this, but memorize 0 to 15 once. Okay, chunk by powers of 2. I see. Bits overlap, which bits differ, which cancels out. Binary writing is a training tool, not a production tool. Holy. We just gotta memorize. Two to the 5 is 32. 2 to the 6 is 'Give me a bunch of and let's go with this. Give me random powers of 2. Four. Power 7 is 128. 1. 2 to the power of 10. I don't know. 200? I don't even know. I need to be able to speed that. 2 to the power of 5 is 2 to the power of 5 is 32 or 64. Because usually I would list them out. I would go. I need to be able to mental math it though. 1, 2, 4, 8, 16, 32, 4, 28, 256, 512, 124. This is how you grind. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I just gotta memorize this and internalize this. This is cooked. Okay, do power of 2 drills. Because with powers of 2s, you need to be able to just pump them out. Be right back. Let's grind more Zor. Two to the power. 2 to the power 3. It's 4. 2 to the power 3 is 8. Man, this is rough. Getting good at competitive programming is rough. Man, this is rough. Damn, Bunny Boy, that's crazy. That sucks. That's so long. It took me a few months as well. Hopefully you can pass it. Hopefully you'll get it cleared. Man, why is competitive programming so difficult? This is actually torture. Like trying to get good at this stuff is torture. Eight, 7, 1. Two. You gotta mental math this. To the power 12. I have to use Anki. Yeah. Okay. 2 to the 5 is 32. 2 to the 10 is 10 to 24. Yeah. That's how I was thinking about it in my in my mind, I was trying to anchor it. Is that? Man, getting good at competitive programming is difficult. This is gonna be a long, long grind. Long, long grind. But we need to work on our weaknesses. Give me another 2 to the power test. How do you do go test mode? Quizzes. I didn't get 3 out of 4. Did you? I couldn't solve this one. Good job, man. Good job. Forgot the anchors. Ten 24. 2 to the power 3 is 4. Shit. 8. 2 to the power 12. 496. One. What's 2 to the power 5 again? 32? Yeah. Okay. 28. 2 to the power 15. Oh, shit. So I'm starting this late. 2 to the power 15. Is 6 months of LeetCode grind? Yeah, 6 months of LeetCode grind is definitely enough. You just need like 2 to 3 months of actually deliberate practice. I literally don't know. Oh wow, I guessed that. 11. I just need to memorize the anchors. to give me 20%, that will, what's the 80-20 rule? Lead to everything else, anchor plus equals, never compute from scratch. Jump to the nearest anchor, double or half. Yo, chat, how do you guys compute binary numbers fast, or 2 to the power is fast? Do you do the same? Do you do anchor as well? Then double or half? What's everyone's strategy? Like, what do people do in their head? To memorize these anchors. It's all good, bro. It's all good. It happens. Just keep grinding. I could only solve 2, so you're not that far from me. Zor toggle bit. Same power cancels. Different powers add. Cancels 4 and 8. Bro, I can't talk about my work, honestly, on the live like that. It's a public company. I could get in trouble. Especially if I leak something that's not private information. I don't run interviews, but I think that's the case. That's what people are saying. I don't run interviews yet. I'll probably start running interviews soon. What do you mean by? Yo, Tens, what's up? Yo, how'd you perform? I see. When do I do my streams? Dude, it really depends, but I'm gonna try to do them after each contest. So usually in Pacific times, probably 9 a.m. Pacific times and like 8 p.m. Either 9 a.m. PST or 9 p.m. PST. Probably focus on. I'll just try to do 9 a.m. PSTs. 9 a.m. to 11 a.m. probably. Please cancel. Okay. I don't do ad coder, but should I? I might start. Yo, do y'all do competitive programming too? My goal is to become just focus on code forces and Liko. I think you're probably gonna get over. Yeah. What are you getting cooked? So how do you pin this? Somebody's asking how do you manage work-life balance? That's a good question. How do I manage work-life balance? Honestly, I prioritize work a lot. I'm super career oriented, career focused. The main reason for that is just so I can make money. I like making money. Yeah, exactly. So honestly, for the past 5 years, probably for the last 10 years, I'll work over 8, 9, 10 hours a day. Even in uni, I was grinding. I pretty much just keep grinding. The way that I balance it is I try to go on a lot of trips. I go to the gym 4 to 5 times a week, 6 times a week. It's a lot, man. It's a lot, but it's worth it. What's my daily routine? No, I don't have a wife and kids. My daily routine is today. I've been waking up early, so usually I try to wake up from 6 to 6:30. So it really depends on the day, right? Someone's asking us. Let me see. Yeah, I can try that later. So my daily routine is pretty much wake up at around 6 to 6:30. So I'll say my daily routine for a weekday because that's 5 days of the week, and then on the weekends it changes. But usually I'll wake up from either at somewhere between 6 to 6:30, and then right now I just been doing code forces in the morning up until 9. So from 6:30 to 9, I'll get 2 to 2.5 hours of code forces. Usually around 2 because I have to get ready for work, and then from 9 to 5, 9 to 6, I work, and then from let's just say 9 to 5, I work my job, and then from 5 to 7, I go to the gym, and then from 7 to 9, I usually do more questions, and then I usually start dimming the lights at around 9, so it primes me for sleep, and then I'll like read a book or something, or do a little bit of social media around after 9 till I go to sleep, and then repeat. It's kind of my schedule right now. Should we beat ourselves? Yeah, we should. By the end of the year, we're not going to be flopping like that. Tens, honestly, it's a lot, but I have a lot of fun doing it. And during the day, I'll be talking with friends, like hanging out with people. I'll find ways to mix it in. But I'm on grind mode right now. It all depends on the time of the year, though. Some in different times of the year. If it's the summer, I'm not grinding that hard. I'm traveling all the time. Like in October, I was pretty much gone. I was in like last year I did 37 flights. So I've been traveling a lot too. I'll show you all my flight tracker. What's the vibes today? Bro, I'm just grinding more questions. I think I'm focusing on bit manipulation right now. Any tips for bit manipulation? This one? So this year I'm gonna go to Greece, I'm gonna go to Italy, then I'm gonna go to Japan, and then maybe one more spot. Nice, this is perfect. What does this book cover? Does it cover math as well? Is this free? Holy crap, this is best. No. Oh, okay. This is where I need to get into eventually. No, you're good, man. You're putting so much information at me, but it's good. It's good. This is because you already like put me onto Alchemist, right? You put me onto this, but I need all this information. Yo, you should just do the contest. Let's read the bit manipulation one real quick. Yeah, I did the lead code when I flopped today, but we're gonna bounce back tonight. I'm gonna read this right here. In program, an n-bit integer is internally stored as a binary number that consists of n bits. For example, C++ type int is 32 bits. Yeah. Here is the bit representation of the int number 43. The bits are indexed from right to left. To convert a bit to a number, we can use a formula: 2 to the 0, 2 to the 1. Yeah, I get this. The bit representation of a number is either signed or unsigned. Usually, usually a signed representation is used, which means that both negative and positive numbers can be represented. A signed variable of n bits contain any integer between -2 to the n minus 1. Yeah. Okay. Why is the twos complement used? Dude, I remember this from school, but I was just like getting cooked on it. Oh, I need to learning a lot this morning. It's crazy. Take a breath. Oh, okay. But why do you have to take the complement? Yo, appreciate you. Yo, realistically, how many concepts should I learn in one day? I feel like I'm trying to cram all the subjects. But realistically, what for y'all, like how many topics would you cram in one day? Do you just go one and just spam it? Yeah, I'm definitely bad at this bit stuff though. I focus on system design when I'm trying to get a job, but I'm not trying to get a job right now. I'm trying to actually get into competitive programming. Your Michael's up. I have some. I'll send you my videos. Check my playlist out here. Yeah, this is the competitive programming book. Zero one equals zero. How do you actually get good at Sweet? Just keep grinding out projects. Getting good at Sweet. The thing is, in my day job, I'm the reason I do competitive programming is so I can just think sharper and cleaner. I already been doing leak code for so long, and I f- I'm not trying to get an expert. I'm just trying to get to my rating, that rating that I want. Suhar, like, what type of projects? Man, what type of projects will it take you to be good? I would just say I'm gonna send you a video. Do this one. Watch this video. And x and 1 equals 1. If okay, more generally, x is divisible by 2k exactly when. Yeah, and makes sense. Or but yo, Sue, like Sue Arena. Honestly, when it comes to coming up with projects, you shouldn't ask somebody for what project to build. You should try to figure out projects yourself, as in like look for problems in the world, look for things that can make money or things that you see people around you who need something, try to build it. That's more the way I like to do it. If you just try to build random projects, it's pretty boring because no one will use it. You can go try to build a compiler, try to build an operating system, try to do like just try to build things you're motivated to build. Like there's not I get that question all the time of what project should I build, but I don't really like that question. Yeah, build don't just build projects, try to build products. I 100% agree because in this age of AI, anyone could build any project. Try to build products and get people on the project on the product. 100%. That's exactly what that guy just said. Okay. I think we learned store this in memory. We'll revisit this again tomorrow. So how does that even solve the problem at the end of the day? I work I'm pretty much a product engineer. Mostly back end though, back end. All right. Taking a quick break. And then how should we study bit manipulation? Chat, let me know if you've ever grinded bit manipulation. Dude, is this alternating Zor? No way. Alpha, how'd you get good at bit manipulation? Okay, I'll read that. Okay. Yo, Tenzim, could you actually teach it to me? Would you be able to teach it to me on the spot? Or and or probably Yeah, give me some good questions. I need to put some research. I'm like very noob on bits. So what else should I know? Learn the standard rules. No, not. I'm not trying to get to that fast exponentiation yet. No, we're just talking about how to get good at bit manipulation in general. Yeah, I haven't really done the bit. I completely ignored bit manipulation. Yeah, I'm gonna give the contest. That's coming up in 8 hours or yeah, 8 hours. I'm gonna do that one. So I'm gonna rest soon. Just I'm just coming up with a plan for studying. Orbit zero. I'm not trying to get the DP part. I just need some Zor fundamentals. I need money too, man. Let's get this money this year together. I'm not stopping for the next. Let's get it, man. Let's get it. I'm not stopping either. Me and you to the top. Translations, prefix words. For real. Same. Caesar, what's up? Mods in the building. Get ready to lift. What time are we lifting? Mods in the building. What time are we lifting? This thing is literally destroying my brain right now. Okay, let me know. Maybe like noon? Yeah, let's go noon. Okay, I'll hop on in a sec. Let me just like summarize all these notes. Give it XOR quiz. Then I was quizzing it on like 2 to the powers. Yeah, we learned anchoring. Yeah, I think this is all we need. This is all we need for now. So summarize what we learned and store it in memory for us to study later. Okay. Okay, we're gonna review this in a sec. We'll take a quick break to let it sink in, and then we're gonna grind this out. Yo, this is what it takes to be great at this stuff. This is what it takes. We're gonna do what it takes. At all costs, we're gonna be up this year. I'll be right back. Okay, let's look at these notes real quick, and then we'll call it. Bit manipulations Zor study summary. Zor core properties must be automatic. X to the X is equal to 0. That's canceled. X, yeah, because it's the same number. They just cancel each other because all the bits are turned on. We'll jump on Chord. We can here. Let's hop on right now while I discuss this, and then maybe you can walk me through some of it. Here, I'll just like hit you up directly. Here. Wait, my AirPods are low. Let me charge my AirPods for like a few minutes, then we'll do it. Okay, let me read through this, then my AirPods should be charged. Or yeah. Implication: ordering and grouping don't matter. Matching values or matching bits cancel out. This foundation of prefix XOR. XOR behaves like addition, mod, 2 per bit. Makes sense. Per bit, pretty much just figure out the count there and then mod it by 2. To see if it's going to be on. XOR keeps bits that appear at an odd number of times. Bits appearing an even number of times disappear. This explains cancellation, prefix XOR. Why XOR is great for parity style problems. Powers of 2 anchoring. Remember 1, 2, 4, and 8. Yeah. Gives me on random 2 to the powers. Yo, Tens, how long have you been doing this competitive programming stuff? One, 8, 2 to the power 5, 32, 4, 128. They're too easy. Why is it going up by 1? What? Power 4, 16. 64. So 2 to the power 5, so 2 to 6. 1. 2 to the power 3, 8. 2 to the power 5, 32. 2 to the power 6, 64. Yo, give me hard. 2 to 5, 2 to the 8 is 256. Yeah, because 8 bits is a byte, and that's 256. This is kind of helpful for system design, honestly. Must know cold Zor toggles bits. Same byte twice cancels. Used for parity, prefix or uniqueness. Keeps the bits that are on in both. Yeah. Using is used for masking, checking bits. Makes sense. Or keeps bits that are on in either. It just has to exist. This one has to exist in all. This one, it has to exist an odd number of times. Is there anything besides Zor and or is that pretty much it? Is bit manipulation just Zor and or? Okay, not. Prefix of R. Mod prefix of L. What's prefix of R? Is that means just keep zoring? How do you generate the prefix of R? Do you just zor everything up to R? So you do zor index 0, index 1, index 2, and zor all those together? Okay, I'm at 31%. Let's chat real quick. Pop in the lounge. Yo, I'm in the lounge. 10.
Hello?
Yo, Sammy, what's up, bro? Can I just call you Sammy? It's way easier.
Yeah, you can call me Sammy, it's good.
But
Yeah, I've been watching you for a while. Or I guess
can you hear me?
a couple
Okay,
couple
there you go.
streams, but and okay, so bit manipulation is what you're trying to tap into.
Yes, sir. It's hard though.
Yeah, I mean I
Honestly,
can
yeah. Give me
Mhm.
give me a rundown.
Yeah, okay, so I have my notes. I can send you my notes as well. It's just from school, like the digital design class, but I kind of tailored it for Code Forces.
Oh, sick. Yeah, can you send it to me? Send it to this account if you have it. Yeah, I'll
Okay,
go
do you want
over
me to
it.
text you? Do you want me to text you on this account or the other one?
This account.
Or okay.
And
All
then
right, so I
just like
guess
walk me through the notes.
okay. So I guess like just very like, elementary, we can start with like what even like a number is in binary. So you got 43, right? So like obviously that binary is just 0 or 1s.
Yep.
And so each of these are powers of 2 and we always go from LSB, which is like this one the most left to the MSB, which
What
is
you're
the
sharing.
most right.
Let me see.
Oh yeah. I didn't write too much, so nothing really happened. Yeah, do you see?
Yeah, I see.
Oh yeah, so this is like in decimal. So base 10, this is in binary, so it's just gonna be like 0, 1, base 2. So we always read it from LSB to MSB. So LSB is just the most left bit, and
Yep.
MSB is like you just go all the way to the most right. So we know that in binary, like given some random, you know, each one, since it's base
Wait, least
2.
set bit is you mean going to the left?
Yeah, okay. So this one is called the least significant bit, right?
Makes sense.
Just because it's here, but also mathematically, it's because if you only have one, just the number one, the only way you can represent that is just 2 to the 0 using base 2, right?
Mm-hmm.
So this is just the least value ever that can ever happen.
Yep.
And then if you have another number here, or I guess it should be a 1. Can I go back? Yeah, okay. I guess if this is a 1, then you have 2 to the 1 because this is the first or I guess second digit, but we count from zeros because 2 to the 1 will never be 1. You want to have 1 inclusive, so with 2 to the 0 we count it as that. So 2 to the 1, that's 2, and so then this would now be in this binary representation. This is the most significant bit, right?
Mm-hmm.
And so if you have multiple bits, it just be the rightmost bit being the most significant because it just has the highest power.
Mm-hmm.
And then this is the most least because it's just 2 to the 0 if it's
Mm-hmm.
on, right?
Yep.
Okay, so now to convert like 43 into I guess 43 is kind of a big number. I
For
actually it's fine.
43, I think the way I would do that is figure out the anchor. So 2 to
What's
32,
the
which is like
anchor?
2 to the 5. So it's to be like
Oh,
the fifth bit is like 32. I'd break it down like 32 and then 8 and then
yeah.
and
What I
then
would do,
3
I mean,
and 2 and then 1.
I
Like,
guess
go
yeah,
ahead. What would you
yeah,
do?
yeah. So basically, what I would do is like, um, I never heard the term anchor before, but basically, you just take a greedy approach and you just use the most significant, like power to 2 that's like, can subtract it. So obviously, 2 to the 6 to 64, you can't subtract
Yeah.
because then this has to go in well because in binary, right? If you have n bits,
Mm-hmm.
so 1 to 1n, this is like 0. The representation you can represent in this will always be up to 2 to the n minus 1. This is the highest value you can ever have.
Mm.
And we can just do what's it called, like an example of this is like, I don't know, let's say you have 101, or I guess 111. So we have 3 bits.
Mm.
So 2 to the 8, or 2 to the 3 is 8, but we know that this is 2 to the 0, 2 to the 1, 2 to the 2. So this is 4 plus 2 plus 1 equals 7. So, or this should be 2 to the n minus 1 here, sorry. So yeah, it should be that. So it'll always be this. So we don't want to go overboard, right? And we also don't want to go too low because then, that's not how it's gonna work. Because if you have like a lot of like a really small number and a lot of digits you can work with, going with
Yeah.
the most lowest doesn't make sense. You want to maximize the left side first.
Makes sense. So you just find the closest 2 to the power.
Yeah.
So it's 32 here
So
at this for this one.
yeah, because this can fit in a range from because 2 to the 5 is 32. But if you have 5 bits, you can actually represent what's it called, 2 to the 6 minus 1, because it's going to be 32. And I hope this is like off the top of my head, but basically it's like 32 plus 16 plus 8 plus 4 plus 2 plus 1, and this is just 2 to the 5, 2 to the 4, 2 to the 3, 2 2 1 2 0.
That makes sense.
So
Like
it's
2 to the
32 plus
6 minus
16.
1 because 2 to the 6 is like the upper range because if we had everything with ones, right? Like 1 1 1 1 1, if we increase it, then
Mhm.
it'll just go 1 0 0 0 0 with 2 to the power of
Exactly.
6 bit being set.
Yeah. So yeah, that's like in this example, this having 5 bits can give you 2 to the 6 minus 1 possible, like, highest value.
Mm-hmm.
And so I guess a really cool trick, or just remember this.
Yep.
So if you have n bits, you can represent 2 to the n minus 1, like max value. Okay.
Okay.
Okay, so since, let's say
Wait,
we're working
wait.
with like
Let me
5
look
bits.
at that for a sec. If you have n bits, you can represent 2 to the n. So if we have 5, 32, we have
Yeah, so
5
5.
bits,
Mhm.
we could only represent up to 31.
Oh,
Or is
my
it
bad. If you
2n
have
plus
6
1?
bits. Oh, no, it's just n minus 1. So in this example, we have 6 bits. So 1, 2, 3, 4, 5, 6, right?
Yep.
Oops. So here, our max exponent is 2 to the 5, right? Because we're counting from 0, but
Mhm.
we have 6 bits.
Okay.
So you see how the max most significant bit will only have a value if
Yeah.
it's on just 32. So if all these are on, then you go down the 6 bits and you
I see.
get, okay, for 6 bits, my max value is just
Yeah.
32 plus 16. I added it and you get 63. 2 to the 6 is 64. So you just, you know what I mean?
Yeah. Like, would you ever have to use that equation in any code forces questions that you saw?
Not necessarily. I mean, you have to know this to know how, like, I mean, it's kind of like knowing like the spamming a pattern versus like knowing like what the fundamental is so I can work around with it. Because I
I
feel
see.
like most problem solving in code forces, at least in my experience, is not like, oh, do this and that, and oh, this is must be a like DP problem or greedy problem. Like that never happens. It's kind of like, man, I really have to go to the fundamentals to see what I can work with.
Yeah, I
Because
see.
there's never been a crazy problem. I don't do crazy problems, but even the highest rated problems I do, um, it's never like crazy data structures. Like remember yesterday I was talking about like how you don't need a max heap, you just have to like sort it and then you can do it. You mod the
Yeah.
value and then that's yeah, so like the biggest thing I can tell you, I guess advice-ish kind of is like you need like logic for
Mm,
div 2 ABC. You don't really need data structures.
I see.
Because if you spam a data structure, you're gonna be putting yourself in an overkill, okay, now how do I work with this structure now type of situation versus like having just your logic lead you the way. And sure, it might lead you to a data structure, but don't just boom lead code. Because I feel like a lot of lead coders they just like, oh, I see this as a find the maximum number of ways I can do this. It's like, oh, it must be
Yeah.
DP. You know what I mean? It's like as you
Yeah.
can't doesn't make sense.
Yeah, I get
So
it.
yeah. So just make sure you know the fundamentals.
Like
So
that
I
that's
guess
what's
the
happens with me a lot because with like leak code forces you to just simulate half the time, but simulation will TLE and code forces 90% of
yeah,
the time.
my biggest thing is like in problem solving in general, because coforces is like in Olympiads as well, you're not just spamming patterns. You have to think about it logically and like see because it's not like with patterns. It's like oh, I can apply this to one general thing to so many problems.
Yeah.
With really unique questions like code forces, you're like, man, I just gotta solve this one problem. Are there any observations I can make that can solve this one problem?
Yeah. Sick.
Because doing something that's like general will never. I mean, maybe maybe you'll get like a problem you saw before and it follows some pattern, but never. There's one quote on code forces from a discussion I saw. It was amazing. It said that this guy was responding. This guy's like a master, right?
Mm.
Rated, responding to some other guy, and he was like saying, "Oh, how do I recognize if this is a TP problem or greedy problem?" And the guy responds, the high rated one, who's like, um, you know, spamming patterns and trying to figure out what type of problem that question is a horrible way to problem solve the question. So you have to make your observations step by step. And yeah, see patterns in the problem, but don't just spam something just because you
Yeah.
think you saw something before. The worst thing is like, oh, this must be this problem I saw before, and you do it, and you just completely wrong. Now you have to try to debug something that worked on a previous problem, but could be the complete wrong approach because your logic was off, right? So
Yeah. No. What's your background
yeah.
again? Are you in school still or you graduated?
Oh yeah, I'm in school. I'm a
Nice.
senior, so I'm only taking one class. So I just like spend the day
Oh,
like
that's
doing
sick.
math and code forces.
That's
But
sick. Like what school?
I go to UCI
Nice. Dude,
in
that's
yeah
sick.
UC Irvine.
Yeah, yeah,
Mhm.
I know where that. Did you already do internships and stuff? Like, are you planning on that?
Oh no, I actually DM'd you about this. I just been doing research, but for the past like 2.5 years, with like a reason why I kind of know some of this stuff is also because the research I've been doing
What are
is
you
in
doing
like
research in,
architecture.
like
But
AI or?
oh no, I don't like AI.
Okay.
I actually like try to avoid that much as possible. But um, I in like architecture and like compilers and like stuff. So like basically, what I try to do is like parallelism.
Yeah.
Yeah, so you know how when you optimize a program, you basically get like a you know some loop vectorized optimization or something. You have a for loop that has independencies to make your code faster.
Mm.
So current like compiler heuristics don't make it as ad hoc to fully take out the potential of that program. So my research is just like,
Damn.
can we really work on the assembly level? So yeah, if you want to learn assembly, I can help you.
No,
But
I'm down.
I,
Like, what are you in your masters or your?
oh no, I'm a undergrad. I
Okay.
actually only coded like, and started my research like my junior year, my beginning of the junior year. The first 2 years, I was kind of like it's like trolling. I was
Yeah.
playing Valorant every day, but and then I was like, oh man, I'm behind, and so yeah, I don't know. Like I said, like my first for loop, like in the text I sent you, it was like in like October of 2024,
It's
like,
crazy,
and
man.
now
Yeah,
like
no,
here,
you're
yeah.
good.
So I don't have that much experience. I'm not that good,
Yeah.
uh, but I appreciate that. But I guess one thing we can say here is that the question you had about why do you have to complement it and plus one
Yeah. Like, what
when
else?
you have a
Just teach
negative
me
number.
everything else that you know about the bits, real quick.
I don't know too much, but basically, like let's say you have a number. Oh, I should tell you this too. This is very simple, very light. You have a number like 0, 1, 1. This equals 3. Can you tell me why equals 3?
Because 2 to the power of 0 is 1. 2 to the power of 1 is 2. You add those up.
Exactly. Okay, so the reason why we want to complement it is because I'm gonna just say it just because I want to. This bit will never change until I want a negative number, and that's fine, right? That means that your true potential or maximum value would be 2n minus 1 minus 1. So this is mathematically just because like this is like kind of off the dome, but should be good enough. Because if you're just subtracting a bit from your representation, you're just using this, and this is only if you have 3 bits, now you're only using 2 for the representation of your max positive number. It'll be just this, and this 2 squared minus equals 4 minus 1 equals 3, max is 3, that kind of stuff, right? So I'm gonna just say, oh, see, you didn't get that's fine. It's just saying like why it's just 2 then minus 1. So you just take off a bit. That's all it is.
Wait, can you repeat that?
Um,
I need that to sink in. That's important.
oh, I got you. So let me reverse this so I can go step by step again. Okay, so we're here, right? So I should erase this because it might overwhelm you. Okay, so I'm gonna say this is a signed bit. Okay, I'm gonna say that this bit will never be touched unless I want a negative number.
Okay.
And once I have this thing will be on. So if I want
Let's
like
work with an
negative,
actual sign bit. Let's say 8. 2 to the 8, like a blind byte.
oh, you kind of lagged for me. What do you say?
Or are you lagging? Oh shit! Give me a sec. Give me a sec. It's lagging
Okay, okay.
again. Okay. I was saying let's work with a signed byte.
Okay. So I guess okay. Let's do this. So let's
Cause like
say,
two, this is not like a. They would never use the third bit as signed as a sign, right?
oh no, this I'm just gonna say that this is called a
Okay.
sign bit,
Okay.
meaning it can be 1 to indicate it's negative, but it also can be 0 to indicate it's positive.
Sure.
Nevertheless, it has a sign, right? Whether it's positive or negative.
Okay.
I guess you can say like only negatives have a sign, but you know what I
Yep.
mean. It's just an indication. Oh, by the way, bits can represent anything you want. Like they can represent like numbers if you want, or letters if you want. Like you
Mm.
can have like some binary that goes up to like how many letters are on the alphabet, and then just
Mm.
have denote like 0 being A and 1 being B, and you do that, and it's really cool because you can do DP optimizations without having to do like mapping between letters and numbers to for your Python list. You can just like literally say like, oh, I declare 1 to be this and 2 to be this, 2 to be A. So it's very like that's one of the biggest things about binaries because they can represent anything you want. It doesn't have to be a number.
Nice.
But it maps to a number, so it's really nice. Um, okay, so yeah, so I guess the equation I put up here, I'll drive it again. I hope this is right. This is what I do all the time, so hopefully. But we see that since I declare this bit, basically I don't want to use this in my maximum
Yep.
value representation. I'll only work with these 2 bits.
Yep.
Therefore, my max representation is remember it was just like 2 to the n minus 1 over here.
Before.
Yeah. Now since I only use 2 bits, it's just minus 1.
Yeah. Okay.
So like, and we can see that, right? This is the max value here because we're not using this, so it must be just that all these guys are on the
Yeah.
right side. So this is going to be 2 to the 3 minus 1 minus 1, which is 2 to the 2 minus 1 equals 4 minus 1 equals 3. So our equation works, right?
Yep.
So now we want to convert this to -3. let's just say. So there's a formula for it, and I'll tell you the specifics of why that complementing it and adding that 1 is very important. So let's say you have 0, 1, 1. That's your 3. You want to turn it to a negative 3. So 2's complement, right? This is the algorithm. It's you not it. So not is like it's a per bit operation. So it doesn't have any independencies. It just like per bit do it.
Just flip
So
every bit.
yeah. So it's 1, 0, 0. So now we know that the sign bit's negative. So okay, we're working with a negative number, right? And then you add 1. Oh, I think I did this wrong. I don't know. 1, 0, 1. I feel like I did this wrong. It should be I don't know. Okay, but let me write this on paper. But basically, the algorithm is negative b, negative binary number equals not b plus 1. That's it. Let me make sure this is right. I don't want to trip you up. So give me 1 sec.
Yeah.
Okay, it does seem right, and I can actually check. Oh, you should use this decimal to binary. Okay, it seems right to me. I hope it's right. If it's not, then use this calculator to justify. But this is the formula I followed. So yeah, yeah, and also you'll see that there's a bunch of 1s. It's because like there's extending it to 16 bits, so it's like 0, 0, dot 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 0, 0, 1, 1. So it'll be 1, 1, dot 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 1, 1 to 0, 0 plus 1. So that's just 1, 1, dot 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 1,
Yeah.
1. Yeah, like that. So that's what they did. And when you extend a binary number, it's always to the left side. Actually, that's not necessarily true, but in this case, it is. So yeah. Because if you want to extend a number, you always just want to add like more potential for a bigger thing. So you add more powers of 2 to get it. But yeah, that's kind of like the theory behind it. I guess in practice, you need to know how this works because I saw there's one guy named Jiangli. He's in Codeforces the guy named Jiangli,
No,
the really crack guy.
I don't know any
He's
code
like,
courses guys yet.
he's insane. He's like number like 5 I think now.
Holy crap. Guys are getting
Yeah.
super red.
Yeah. Also, do not look at this. I don't do contests, so you can ignore that. It's very embarrassing. But yeah, so he used this equation on one of the problems when I was stuck. It's because this is what it is. And also in C++, I'm not sure about Python, but probably it has to. Using negative b also works.
What's
It just
negative
converts it.
b?
It just like the negative number that you
Oh,
have
okay.
equals the not of that number plus 1. Yeah. And so now let's say you have negative 3 and you want to convert it to positive 3. And we know this is negative 3 because this is not equal to 3 right now, right? Like the binary representation, you don't know what this is. Because this to me this just looks like 1. You know what I mean? Like 2 to the 0, we're ignoring this. And that's not right. So you want to convert it to a positive number if you want. It's the same thing, same equation. You have 1, 0, 1 equals the not of 0, 1, 1 plus 1. So basically you do it like an order of operation situation. So it's 1, 0, 0, 1 minus 1 equals not 0, 1, 1. This is 1, 0, 0 minus, or that's it, equals not 0, 1, 1. And then you want to just not both sides because. Oh, you're back, Chimps?
Yeah, what the Yo, my Wi-Fi is tweaking. I had to switch into this is crazy.
You're good, you're
It
good.
crashed like 4 times today. I'm so pissed.
Is your live end, or are you back?
Yeah, I'm in.
Okay.
Bro,
I guess
I actually need to
just
fix my
some.
Wi-Fi.
Hmm.
Okay, what
Do
are
you
you
have
saying?
like? Oh no, I was just saying like for Wi-Fi, is it because it's like the load is so high, or like it's just like bad? It's like like icy, the people
Bro,
who
I actually
control
don't
your
know.
Wi-Fi, is it
Actually,
bad?
I actually don't know. It just cuts out. I haven't had the chance to troubleshoot it yet.
Yeah.
Can you hear me?
Yeah, I can hear you. I can hear you.
Okay, but because yeah, now I'm literally on just on my data.
Oh, okay. Do you want to just end it there, or you want the XOR thing to help you, and I leave or whatever you want?
Let's see. Wait, let me try to switch back to my regular Wi-Fi. Give me a sec.
Mm-hmm.
Or just explain it now real quick.
Explain it now.
Yeah, yeah.
Okay, so oh yeah, so I was gonna talk about the gates,
Oh,
which
the
is just like the
gates.
XOR ands and stuff. Yeah. So
Okay, wait, let me
there's
let me switch to my Wi-Fi. One sec.
okay.
Gonna switch. Is it working? Can you hear me?
Yeah, I can hear you. I can hear
All
you.
right, perfect. Holy, it's actually crazy.
Maybe I should just do. All right, you want me to start?
Yeah, let's go.
Okay, so ands. Let's say you have two binary numbers. Let's call it or actually okay. Let's say you just have one number and you want to and it with another number. Let's just say those numbers are 1 bit long. So let's say you have a number x, number y, both are 1 bit long. What's your output, I guess? So let's say x is 0 and y is 0. Just like, 1 bit numbers, you can either be just off or on. Let's just say
Yeah.
both are off, right?
Mm-hmm.
So if you and it, you get 0. If you have 0, 1, so I flip 1 on, then it's still 0. Why? Because for ands to work, both have to be 1. So both have to be true.
Yeah.
This trips me up a lot. I'll be honest. Like sometimes I'm like, oh, both are the same, so it has to be,
Yeah.
like one. But it's just make sure you get it. And then so 1, 0, same thing. 1, 1. There you go. Right. That's your and. So I guess there's a really cool pattern that you can see. If you and anything, so this is the and symbol. Oh, that's not the and symbol. Wait, how do you even do the and symbol? It's like okay, I don't know. Well, I'll say this. If you and something with another number, so let's say you and x with y or y with x. If you and x with like or a number with 0, you're gonna get 0.
Yeah.
Okay, why is that the case, James?
Because 0 has no bit set, so it's pretty much you need all the
Yeah,
bits set
exactly,
across all the like if you have a subset
exactly.
between the two
So
numbers,
let's
you need all the bits set.
yeah. So I guess I haven't actually done this, but I saw people do it. So this is like talking out of like my ass, but basically if you're doing like a bitmask TP and you want to ensure that states are on or off, and you want to be like, oh, I explore this state, so I'm gonna forever want this off. You just and it with 0.
I see.
So no matter the binary number, so let's say it's like 1, 1, 0, 1, and you and it with 0. Remember how I said like kind of extends all the way to the right usually?
Mm-hmm.
So in this case, 0 just 0. So the whole thing, 1, 0, it has to be all 0, right?
Yeah.
Because it just no matter what it is, it's 0.
Mm-hmm.
Um, yeah, and yeah, that's that. There's also another thing. If you have like a number like this, or it doesn't even matter what the number is actually, but if you have like that, and you want to and it, what do you get? I mean, just follow the truth table, right?
Yeah.
1, 1 is on, 0 is off, 1, 1's on. So you can see that if you and something with 1, it keeps the same like thing, right?
Yeah.
If you and something with 1, it keeps the other.
Mm-hmm.
Yeah. So yeah, it keeps the other, not the same. Yeah, so that's that. So that's and pretty simple, pretty cool. And make sure like for representation, like this is all very important. Like there's always cases where I'm just anding stuff. Like I know XOR is the most common, but like you can do crazier stuff knowing like other things. Like
Mm-hmm.
I mean, these are all the fun. There's only 4 fundamental gates: XOR, OR, and
Not.
I guess there's only 3. I don't know, or not. Yeah, 4. Um, so yeah, I already told you about not, right? Just like flip
Yeah.
each one from any order, just flip them. So you now have OR. So let's say we have X, Y, and our output. And let's do the same thing. Let's say they're 1 bit, and I'm gonna just be like, they can only be on or off. Let's go through all 4 combinations. So 0, 0, both are off. Yeah, that's off. So 0, 1, the cool thing about OR is only one of them has to be on for it to work. So at least one. So this is 1, this is 1, this is 1, because at least one is on, right? In any case, usually you're not really doing crazy like 3, 4, 5-way binary ORs. You're in all the questions that at least I've done, it's always like at 2 at a time. So you can just use like a table to like guide you. Feel like if you haven't memorized it yet, like, oh, what is this? You know what I mean? So I guess if we OR something X, Y, you can see a cool pattern. It's kind of, I think you already see it. It's just like if it's 1, it's still be 1. So it's 0, 1, 0, and you OR it. Actually, no, the number for OR is just like one thing with like 0, 1, 1. So let's follow it. So 0, 1, that gives you 1, 1, 1, that gives you 1, 0. So what OR does, if you OR something, or a number with some 1 in some element position, bit position, it'll always be 1. If you OR it with 0, nothing will happen.
Yeah.
Right? I guess in a sense, it's just keeping whatever on the other side. But yeah, because nothing happens, so it has to be the other thing. But yeah, very cool. And then not I already showed you. So XOR. There's also one more called XNOR, which is like it keeps everything that's the same, which is pretty cool. But you'll see how to derive that. I'll show you. And your output. So 0, 0. So XOR, what it does is if the bits are different, then it will be 1, I think. So 0, 0 is 0, so they're the same. 0, 1, they're different. 1, 0, they're different. And then 1, 1, they're the same.
Yeah.
I just want to make sure that's true. And yeah, these are called gates.
Yeah.
Yeah, okay, that's different. So XOR is really cool because, you can see this right here. If you XOR something, then basically what's going to happen is if you XOR like a number with another number, and you follow the thing, so let's say 0, 1, 1 with 0, 1. This example was chosen very meticulously. So 1, 1, 0, 0, 0, 0, and 1, 1 is 0. So what does this mean? What does this mean? If you XOR a number with the same number.
If you XOR a number with the same number, nothing happens.
Or
wait, it cancels them out. It cancels it out completely.
Yeah. So I guess nothing really happens, just 0. But I know what you mean. So yeah, it's called a conditional inverter. I think that's what my professor told me. It's like basically based on it, you can invert it. So yeah, it's really cool. This is very useful. The reason why is because like a lot of questions, at least in my experience, they talk about like how can you have the highest value number, and a lot of the time is like can we keep a number in which we XORed it so this bit, the highest bit, always stay the same, because if you XOR something with 0 and the highest bit, you always get the different one, or like the highest bit, so 1. So that was one of the questions. It's quite complicated. I think it's like a 1300 question. I remember it well because like in a Div 2, I forget a long time ago. Anyway, so yeah, it's very important. So yeah, and then
He's
obviously
asking,
if you
why
XOR,
doesn't he explain why XOR has memory? What XOR has memory?
what do you mean memory?
He's asking, what do you mean memory?
Who's asking?
Somebody in the chat is saying.
XOR has memory? Oh, I'm not sure. Oh, wait, it's because okay. I think this is a trick actually. Have you seen like the really like famous example if you like have A XOR B and B XOR like A and then A XOR B again. You swap the things basically. Like swapping two numbers with XOR. Like this thing. You can just do this and you'll swap it. So it has memory in a sense, I guess.
Wait, what? Here's it.
This is very weird. I have never used this in my life, but
Okay.
yeah, I don't
Yeah.
know. Maybe find a missing number in an array. I guess. I mean, I don't know what you mean by memory. I don't know. I don't know what that means.
I see.
So sorry, you might have, maybe it
Okay.
means something
Let's
else
just
to me with
continue with the
different name.
Zor because I have to leave in a few minutes. But is there anything else besides Zor?
Oh yeah, I guess XNOR, but it's just nodding this.
Oh,
So that means that this is 1001. So that means that when it's the same at work, it's one,
let's see.
and when it's different, it's zero. Um, yeah, I mean, pretty much that's like kind of the basics, I guess, of just what binary numbers are. Any questions or anything? I'll send you my note. It's not that long,
Yeah,
so
yeah.
it's
Send
pretty.
send me your notes and I'll go over it. I think, yeah. No, I think I'm gonna focus. Yo, if you could figure out like a lesson for the math related stuff related to code forces, we can hop on stream. We're
Math,
gonna do that. Like any just
math,
basic math related stuff for code forces.
maybe math is tough because no matter how much I'll explain it, like it really comes down to your individual mathematical maturity and how well you can just see things logically.
But
And that's just practice, right? Unless you're just talented,
yeah,
which both are completely fine.
honestly,
But like,
I feel like I don't know. I've done so many questions. If you just give me a brief lesson, I can internalize it fast. That's the thing. It's more just like I just need to jog my memory on some of the math stuff. If you
I
just
see.
give me like a
Okay.
TLDR, and then I'll
Uh,
figure out which stuff I need to dig deeper in.
okay. To be honest, I'm not really that good at math. Like, I don't know that much math either. Like,
Okay.
I, I guess I can next stream if when will that be? Do you know?
I don't know, maybe
If I can
tonight
make it.
or
Oh,
tomorrow.
tonight
We'll
is
do
bit,
it
yeah.
tomorrow. I'm gonna do the Div 4 competition tomorrow, and then I'll
Okay.
I'll I'll do debrief after that. Div
Okay. Oh,
4
did you
is
solve the
easier, huh?
question? Yeah, diff 4 is meant for like people with this rating. But yeah, is it another 6 a.m.?
Yeah. Do this one in the
Yeah,
morning.
I'm not too sure about that one. You got that. Oh, did you solve the question yesterday?
Yeah, I know how to solve it, but
My analysis of the question was like this is how I did. They only had one line. It's crazy. But yeah, it's I don't know. These guys are good. That's why they always say like, oh, it's obvious to them because they just have so much practice.
yeah, my thing's tweaking out again. All right, it's all good. Thanks for running me down on that though. We're gonna
Yeah,
keep. I need to spend time actually reading and looking over the notes, but
yeah.
we're gonna dig
And
in.
I'm down to like do practice problems with you if you want. If you
Yeah, let's do
like,
it.
if you're like off streams or something, like I'm down.
Yeah,
Like this is all I do other than gymming. So
that's
like
sick.
and homework, I guess. But yeah,
All right, man. Thanks for jumping in. I'll message
yeah,
you.
for sure. I'll send you a friend request on your
All right.
account.
Yeah, because this is my other account.
Okay,
Okay.
it's your main one.
I might actually just delete this account. Let's see. It's just because it's messing up with my other one. I'm gonna fix my Discord, but
Okay.
oh shit, I left the voice. Yo, I'm back. One sec. Yeah. All right, bro. Thanks for helping me out.
I got you. I got you.
All
All
right.
right, I'll see you.
Okay. See ya. All right, Chad. I gotta end the stream because my Wi-Fi is just tripping out. This is ridiculous Wi-Fi. I gotta figure out what's happening with my Wi-Fi. It's tweaking out.